On the second half of the demo, we'll switch over to R to talk about how to interact with Syncrosim using an R package that's called rsyncrosim. And that allows you to create reproducible workflows and to create and run multiple scenarios in the spirit, for example, of a sensitivity analysis. So I'm going to switch over to R. Here I have a omniscape example.r script loaded. And in this script, we'll cover how to reproduce this omniscape example that we just built in the Syncrosim UI. And then we'll run a sensitivity analysis with Syncrosim. So to begin, I'll just load the libraries that are required to run this script. And I'll just highlight the rsyncrosim package here that we will use to interact with Syncrosim. So the first part will reproduce the Syncrosim UI example that we just built. And to do that, we'll use this function here as sim library to open this omniscape example library that we created. And I'm going to load that into this object called my library. And then I'm going to open the project that contains all of the scenarios. So now we're going to create and edit a new scenario, just like we did in the UI. So to do that, I'm going to load that reference scenario based on a radius of 100. And then from that reference scenario, I'm going to create a new scenario that I'm going to name radius 25 since we're changing that variable. And I'm going to name it built in R just to distinguish between the one we created in the UI. Now we'll gather that data sheet, the radius variable is stored, and that's stored under the required tab, if you remember, and the name of that data sheet is just omniscape required. And we're going to store that into this required input object. And then we're just going to assign that radius variable our new value of 25. And then our required input will be saved back into the omniscape required data sheet in Syncrosim. And that's it. And we are ready to run it. So I'm just going to select that and click run. It should take the same amount of time as it did, or a little faster here in R. And once it's complete, all we'll do is grab the outputs that will be saved into this omniscape results data sheet. And if you remember, we have three outputs: the cumulative current flow, the flow potential, and the normalized current flow. And once we have those, we'll plot the results in just a few seconds. Okay, so it's complete. I'll just run this to grab the outputs and place them into their respective objects. And then I wrote a little function here just to plot the outputs in a way that we saw similarly in Syncrosim. And then we're ready to run the plot. The cumulative current flow for radius 25. Here we have for the flow potential. And lastly, the normalized current flow. Just like we saw in Syncrosim. So just before we continue, I'm just going to flip it back to Syncrosim so you can see how you can work between R or Python and Syncrosim. All you have to do is refresh the library, and then the changes that we made in R will be populated here in the UI. So you can see that new scenario we built in R is now displayed here, as well as the results that we ran in R. I'm going to switch back to R. And for the final part here, I'm just going to show you how we could perform a sensitivity analysis using the rsyncrosim. So let's say we're interested in conducting a sensitivity on radius. We have around 9 values, I think 9 values here, and that we're interested in exploring. And we'll save the radius number as well as just for demonstration purposes, we'll save how long it took to run each of these scenarios with a different value of radius. So I coded a loop that goes through those same steps that we just saw. It creates a new scenario based on the reference scenario. Then it gets that data sheet, the required data sheet, enters a new value for the radius, and saves the data sheet back into SyncroSim. Then it takes the start time, runs the scenario, gets the end time, and calculates the total run time that is saved into our data frame and output it once the loop is complete. So I already pre-ran this, and I'll just load the results. We'll take a look at what they look like. So first column for radius and then the run time. And just to finish off, I'll plot it so we have something nice to look at. So here we have how the runtime in minutes changes as we increase the moving window radius.